This is the first of 2 videos about solving quadratic equations by factoring. So we're going to solve each of these equations by factoring and then using something called the zero product property, which I'll define when we get to that part of the problem. So in example 1 here, 3x squared minus 12x equals 0. It already starts by saying equals 0, which is the first thing that we want to do in all of these questions on today's video. Start by making sure it says equals 0. This one does. So we're going to then, next step, factor the left side of the equation, where all of our variables and our numbers are. So we're going to factor the left side of the equation by taking out a 3x. What's left is x minus 4, and it equals 0. Now to solve this equation, the product of 3x and x minus 4 equals 0. Product means multiplication, and when you multiply two things together and they equal 0, it means that one of the two factors that you multiplied must equal 0. So I'll show that here in a different color. If you have something like x times y equals 0, either x must be 0 or y must be 0, right? Because 2 times 7 will never equal 0. 3 times 9 will never equal 0. Only if one of those two things was 0 will the result be 0. So with that principle in mind, we're going to take our factored equation and say that the first factor, which is 3x, equals 0, or the second factor, which is x minus 4, equals 0. And now we've got two linear equations that we can solve. Solve this equation by dividing both sides by 3. 0 divided by 3 is 0. And we'll solve this equation by adding 4 on both sides. And 0 plus 4 is 4. There are two answers to all of these equations. And sure enough, if you plug back in either 0 or 4 to the original equation, they will both give you 0 as the answer. Two answers to a quadratic equation. In this next example, it does not say equals 0, and I need it to say equals 0. So I start by subtracting the 5x so that all of the variables and numbers are on the left and equals 0 is on the right. And now I'm going to factor the expression on the left by taking out an x. Then use the zero product property, which says either the first factor must equal 0 or the second factor must equal 0. Solve this one, and we obtain that our two answers are x equals 0 or x equals 5. Same instructions. The only difference here is the type of factoring we're going to use. I see a trinomial, so I'm going to split it into two binomials. Remember that you're looking for what multiplies to make 35 and what adds up to make negative 12. So we're going to fill in our x and our x. What multiplies to make 35? 5 and 7. And I know that 5 and 7 will add up to negative 12 if I make them both negative. So if I make them both negative, x minus 5, x minus 7. And then I take each of these factors and set them equal to 0. Solve them. X equals 5, x equals 7. This equation does not say equals 0, so I'm going to move everything to the left side and then factor. First thing I notice is that I can take out a 3. And now you can see why factoring is so important. Then I can factor this as a trinomial into two binomials. I'm looking for what multiplies to make positive 3 that adds up to negative 4. So I'm looking at the numbers 3 and 1, and in order to make them add up to a negative, they both need to be negative. Now the factors here that matter are this one and this one. If you tried to take this factor and set it equal to 0, well, there's no x attached to it, and 3 doesn't equal 0. So this factor is never going to equal 0. So we don't even need to include that step. We're just going to include the two that actually have the variable in them. And so x equals 3 and x equals 1. And then a third type of factoring, we're going to start by making it say equals 0. I noticed that 36 is one of those perfect squares. So the number that multiplies to make 36, that adds up to negative 12, is going to be 6 and 6, but they both have to be negative. And this time, because x minus 6 squared equals 0, it's the same exact factor written twice. You only need to solve it once, because this is one of the special cases where there is only one solution. 6 is the only thing that you could plug into this equation that would make it true. And then in this last example, start by making it say equals 0. Take out the common factor, which is 3. And then inside these parentheses, I notice that I have a difference of perfect squares. So 2x plus 3, 2x minus 3. Again, I'm going to ignore the 3 that's out front since it has no variable attached to it. And either this factor equals 0 or this factor equals 0. So the solutions are going to be negative 3 over 2 or positive 3 over 2. And that is all.